Let us discuss overloaded operator. We will look at various overloaded operators, binary, unary, the input, output, different kind of operators. Let me just show which resources will we use. First, in my GitHub repository, there are a lot of programs. We will use many programs lying here. We will also use this CPP reference standard page which explains different operators, what should be their signatures and how it should happen. So let us begin. So let's just assume that we have a class point having x and y coordinates. Basically, it's a point on a 2D plane. And now how do we achieve natural syntax on these points? How do we achieve P1 plus P2, for example? So when we do P1 plus P2, behind the scene, what happens is a function is called whose name is operator plus. Now there are two possibilities. It could be a member function. It could be a member function of P1. In that case, what happens is you call a function like this, P1 dot operator plus, and you pass P2 as the parameter. So that's one option you have. You can implement operator plus as a member function of the class point. We will see it in complete programs. The other is you can have a external function. Typically, it's made a friend so that it can access the data easily. In that case, what will happen is you are calling a function called operator plus, which is not inside any object. It's an external function. So that means you will need to pass both. You will need to pass P1 and you need to pass P2. So any operator, almost every operator can be implemented in both ways, member function and friend function. Some operators, there is a limitation, like assignment operator can only be member function. Let's understand the operator plus when it is done as a member function. So here is the class point and it has constructor, copy constructor, etc. And this is the operator plus when it is a member function. If it is a member function, it takes only one argument. It takes the argument which means the other object. And naturally the first object is star this, is this object itself. On this object, I add another. So I take only one argument. If it were an external function, I would need two arguments, P1 and P2. So it takes the other argument and it computes an object which is the summation of this object x coordinate plus the other, and same for y. This is interesting to note that it takes const, point, ampersand, other. So let's just understand this. If it were to take point, then that means we will need to copy the object. That will not be very intelligent. So naturally we will like to pass by reference. Therefore the ampersand. So we pass by reference. And if it takes a non-const reference, that means only modifiable L value objects can be passed. Temporary objects which are created by P1 plus P2 or some other expression won't be passed. And constant objects will not be passed. So to be able to accept both constant objects and temporary objects, this const is necessary. We use const, point, ampersand. Now let's look at minus, binary minus, as a friend function when it is defined outside. When it is defined outside, this will be the prototype of the function. Name of the function is operator minus. It has to take two operands, first and second, so that it can do first minus second, and it has to return the result. So naturally the same syntax is used at most points, const, class, ampersand, object name. So let's see this in program. So here is the friend declaration. Within the class, we declare that this function is a friend. And this is the implementation. So the implementation is very similar to the operator plus which we saw. The main difference is it takes two arguments because it is an external function. Now let's see unary, plus plus and minus minus functions. So we know that we have the postfix notation and we have the prefix notation. And again, these can be implemented as member function or friend function. If they are implemented as a member function, the object being incremented is this object or star this object. So there is no argument required. If it is a friend function, then the object which is being handled is also passed as an argument. There is one peculiarity that plus plus can be postfix and prefix. So in postfix also I called operator plus plus, and in prefix also I called operator plus plus. So how do I differentiate between them? So there is a peculiarity that when you do the postfix, then the compiler passes a dummy parameter which is a int, which is always 0. This is only to differentiate between the postfix variant and the prefix variant. So let's see the postfix and prefix unary operators in this program. What we have done is we have implemented ++ as member functions and -- as friend functions. So let's see first as a member function. So if it is a prefix, then the prototype is like this. It doesn't take any argument because the object to be incremented is *this. And the postfix, as I told, it takes just an int dummy just to differentiate between the prefix and postfix. So prefix, what it does is it increments the object and then it returns *this. So because it is returning this object, it has the opportunity of returning a reference. And for the postfix increment, it has to basically remember the previous value, increment it, and then return the previous value. Because it is returning a object other than this object, it's returning an earlier state of the object, it cannot return a reference, it has to return it by copy, by value. Let's see the -, the decrement operator. So first we have the postfix. So it takes the object to be decremented as well as a dummy parameter just to differentiate between postfix and prefix. So because it is postfix, it remembers the current value, decrements it, and then returns the now previous value. And the prefix decrement simply decrements the object and it returns the object. It has the option of returning a reference because it is returning the current object itself. The main difference between the member implementation and the external friend function implementation is this additional argument. Now let's say we can add p1 plus p2, that's good, but what if we wanted to be able to add an integer to it also? Assume we had some semantics that integer would get added to the x. So we want to increment the point with some integer. So how do we do it? There are two methods. One method is that operator plus can be overloaded. Operator plus, we earlier defined that we can add another point, but we can have another implementation of operator plus where we take an int and add it. So naturally you can have lot of flexibility. You can say I can add integer, I can add double, I can add another point, I can add some other class object. So you can keep overloading this operator plus with all those different possibilities. So let's see the code for this. There are two functions. One we saw earlier, which is adding a point, and another we defined, we take an integer and we add that. Similarly, we can have even more things. If on this point object we can add some other class object, we can define it for that particular class. We can change this argument. Other method is, you can understand that we have to do p1 plus 30. So if we could convert this 30 to a point object, then we are done. Then we can add 2-point object. So basically you can have a facility to convert this 30 to a point. How do we convert a integer to a point? Because you can understand we are creating an object. We are creating a point from a int. So a constructor will help us. We can simply have a constructor like this. It takes an integer and creates a point. So normally if you have a constructor like this, then even implicitly this type conversion will happen. If you do p1 plus 30, compiler will taking this constructor, construct a point from this integer, and then the points will be added. Sometimes this implicit conversion becomes confusing. Then you can write in the constructor that it is an explicit constructor only. That means you need to explicitly call it. So you can call it using this syntax, or you can call it using the constructor call syntax. Both syntaxes work and you can do a conversion like that. So this is the method 2. Let's see it in code. So in this case, even this constructor would be used as a conversion constructor because this constructor is capable of taking one int and the other parameter is defaulted. So it is not necessary that the constructor must exactly take one argument. It can be this also. We have 2 arguments, but they can be defaulted. So even this will be used as a conversion constructor. So we saw that given int, how to convert to the point object. Sometimes we may want the other thing also. We may want to convert the object to an int. For that, we also have operators. We have operator int. The function name would be operator int. And the implementation of operator int would look as this. Basically, it doesn't have any return type because operator int, so that naturally it is returning a int. It doesn't take any parameter, and it simply has to compute some logic, maybe x plus y or x, and return that integer. This const is simply meaning that this function is not modifying the object on which it is invoked. Now let's consider the input-output operators. We want to read into a point, or we want to write whatever the content of a point to the cout. So how do we overload these operators? Can they be done using a member function implementation? No, because if it is a member function implementation, it would be like cin dot operator greater and then p1. So that cannot work. That cannot work because we cannot modify cin. So it has to be a friend function only. Let's look at their implementation. So because they are external functions, they need to be declared as friend. This is the output operator. You are writing into a output stream. So the class name is oStream. You take a output stream. You take the object to be outputted. You output it. And then you return the output stream. Why do you return the output stream? You return the output stream so that you can do this. You can say cout output p1, then output p2, and then output endl. What is the result of cout output p1? It is again a oStream reference. So it can be cascaded. And when you are taking input, it is very similar. Instead of oStream, you use iStream and you take the reference to the object. This time it is not a const point because obviously you are reading into the object. So you will modify it. So that's the input function. Now let's consider assignment operator. We are doing p1 equal to p2. So the contents of p2 are being assigned to p1. So there are two kinds of assignment operator. Typically, we almost always mean the copy assignment operator, but there is a concept of move assignment operator which belongs to R value reference. So move semantics we will study in a different video, but we'll still have a look at how that code looks. How this assignment operator is different from copy constructor. If you do something like this, point p1, p2, that's a copy constructor, because you are constructing p1. Or even you do like this, point p1 equal to p2, that's also a copy constructor. Why? Because p1 is being created right now. But if you do p1 equal to p2, that means say assignment operator. When you are doing assignment operator, it is important to note that p1 will have an initial state. Maybe if there are some pointers or dynamically allocated memory or some resources, open file, mutex, then p1 may have some resources which are already taken. So when you are doing assignment, one step can be releasing the previous resources and then allocating new resources and copying the data. And if objects have pointers, then one natural choice comes that do I just assign the pointer, that's a shallow copy, both objects are pointing to the same data block, or do I make a copy? So that kind of an option exists. Let's look at the assignment operator implementation in the code. So we again have the point class, and the assignment operator looks like this. The argument is the other. If we are doing a equal to b, b is the argument. And then it returns the reference to this object itself so that it can be cascaded. So one can write a equal to b equal to c. So this is a very simple object. So it just copies the data and it returns star this. We will see a more elaborate assignment operator where we have a nested pointer and we want to copy the data. Such a simple assignment operator is provided by the compiler. So if we have no pointers or references or anything like that, we can rely on the compiler provided assignment operator also. Let's consider this program where we have some dynamically allocated memory. So you can see the constructor is allocating memory. And then we have a copy constructor also. And we have this assignment operator. Let's understand this copy assignment operator. Normally the assignment operator, the main code is same as copy constructor. We allocate memory and we copy the data. But because the left hand side would have some resources, we will like to release those resources. So we can delete it. But there is a catch that if somehow accidentally this happens, a equal to a, where a is that object. So then if we just delete right away the nested pointer, then we are in problem. So Scott Mayer's effective C++ suggests that please check assignment to self. So if this pointer is equal to address of other, then we simply return star this object without doing anything. Otherwise, we delete the resources and we copy. One thing to note is that this code can typically be optimized because we are releasing memory and then allocating memory and then copying. So the question arises, why can't I copy into this memory itself if the size matches? So one can think of optimizing it. This is a simplistic implementation. Now we also talked of move assignment operator. It looks something like this. So when we do move assignment operator, we take a R value reference, which is denoted by double ampersand. What we do is that we simply copy the pointer and we set the pointer in this other object as null. So essentially we are stealing the data. We are like taking that pointer and storing in our object and setting the pointer in the other object to null. So this typically is done if you have some such code, p1 equal to p2 plus p3. So what is the result of p2 plus p3? It's a temporary object which is just about to be destructed. So if that is about to be destructed, why can't I steal the resources? That is the motivation behind it. Now we must have come across iterators or smart pointers, shared pointers, unique pointers. So they all look like pointers. We can do star on them. For iterators, we can do plus plus on them. How does that happen? That happens by overloading this operator star. Here we are talking of the unary star, the dereference operator, not the multiplication binary operator. We have a simple example. MySequence is basically our own container. It has our own storage of multiple types of elements. And we have created an iterator class on it. So the iterator class tracks for the index within our own container and it returns. So the operator star would look something like this. It returns a reference to that element. So it just checks the range and returns that element. It returns a reference because we will like to write some such code. We will like to say star iterator is equal to 98. Let's say we are changing that value. So that's why it's returning a reference. In fact, sometimes we implement operator index also, which will look something like this, operator index, and it can take a index and then you return the reference. In fact, this index can be some other data type also. For example, you would appreciate that if you have a map which maps string to int, then the index operator will take a string. Index operator can be used if you have a collection and you want to have the concept of indexing, similar to what a vector allows or what a map allows. Such an index operator will again take the key as the argument of the function and it will return reference of the element because we may want to modify that element. Now there is a concept of functors, which are basically class objects which behave like a function. That means you have the object and you can call it as if it were a function. You achieve it by this. Let's say you have a class myFunctor and you implement this function operator function call. And then you can give it some arguments, whichever you like, and it can have some return type, let's say double. So now this object of this myFunctor can be called as a function. And this object will have access to the entire state of the object. So it can use not only the arguments, but also the state of the object to do the computation. So this is a tiny example where we have a estimator and we pass some arguments and it returns. So this is the way operator overloading is done. We have covered some good set, but there are more. If you look at this page, you will find more functions. You can have those comparison functions, equal to, greater than, less than. You can have some more functions which you can overload.